Welcome back. This is section 6 of your data project. So we have already found the mean, the median, and the mode. We are now talking about the mean absolute deviation. So you're going to look back at the last page that you had. You already found the mean. In our case, we found it, and it was 75.7. So that was our average. Now we're finding the mean absolute deviation, which is another measure of variability. So what we have to do is we have to take our data, so we're going to write our data in order from least to greatest like we've already done. So go ahead and copy that from the last page. So we had 64, 67, 67, 68, 71, 71, 72, 74, 76, 78, 79, 79, 80, 81, 83, 83, 84, and 86. Okay, so we already found the mean. Usually you would have to find the mean before you did this, but we've already done that, so we don't have to rework it. But to find the mean absolute deviation, we have to find the distance each of these numbers is from the mean. So you're definitely going to want your calculator. You could do it by hand, but it might take forever. So we want to find out how far 64 is from our mean of 75.7. Now, since 75.7 is highest, I'm going to do it first, minus 64, and that tells me that it is 11.7 from the mean. Okay, keep doing that with all the other numbers. So 75.7, subtract 67, that gives me 8.7. This one will be the same then. Since this is one closer, that's going to be 7.7. 75.7 subtract 71 equals 4.7. 72 is going to be one closer, so that would be 3.7. This is 2 closer, so this will be 1.7. Now stop right here. A lot of you are going to say, oh, this is 2 closer, and so you're going to, because this number is bigger than this one, you got to put this one first in your subtraction. So 76 minus, now we're minusing the mean to figure out how far it is away because the mean is smaller than the number we're dealing with now. And oops, I typed in the wrong number, so that won't even help. 76 subtract 75.7 gives me 0.3. A lot of you would be tempted to put 0.7. Watch yourself. When you get bigger than the mean, you have to minus this number, subtract the mean. Okay, 78 minus 75.7 equals 2.3. Now from here, they're all going to, we can just add to it. So this one's only one more, so this will be 3.3. This is one more, so that would be 4.3. One more, 5.3. Two more, so this will be 7.3. Same as that one, 7.3. This would be 8.3, and this one would be 2 more than that, so that would be 10.3. So you can see that our minimum and maximum ones are about the same distance away. The smallest one's just a little farther from the mean. Okay, so we have to find the sum of the distances. What I'm going to do is I'm going to break it up. I'm going to add this one twice, make sure I do it right. Add this one twice, make sure I do it right. Then I'll add those together. Just that way, all it takes is making one typo and it messes everything up. So if you take it in chunks and make sure that chunk is right, then you can add the chunks together. So I'm going to do up here. So 11.7 plus 8.7 plus 8.7 plus 7.7 plus 4.7 plus 4.7 plus 3.7 plus 1.7 plus 0.3. I get a total of 51.9. I'm going to do that again just to make sure. In statistics, especially when you're doing so many numbers at once, it's really easy to make a mistake. So it's better to do it twice and do it right. than to accidentally miss something and be wrong. Plus 3.7 plus 1.7 plus 0.3 equals. Okay, I got the same thing. So down here I'm going to add these up. 2.3 plus 3.3 plus 3.3 plus 4.3 plus 5.3 plus 7.3 plus 7.3 plus 8.3 plus 10.3. I got 51.7. Wow, guys. That shows, look at the distance in this half and this half, because this is just cut in half. That shows this data is actually really well balanced from the halfway point. The added those distances are the same. All right, let's re-add just one more time to make sure we did it right. 2.3 plus 3.3 plus 3.3. Oh, see how I accidentally typed 33? That would mess me up. 2.3 plus 3.3 plus 3.3 plus 4.3 plus 5.3 plus 5.3 plus, oh, I shouldn't have done 5.3. I'm going to minus 5.3. I did it too many times. All right, back. 7.3 plus 7.3 plus 8.3 plus 10.3. I got the same thing again. But you see how even myself, I did 2 errors just trying that second half. That's why it's so important to double check yourself. Okay, 2 times, I got the same thing. Now this will be a lot easier. I'm just adding these 2 because that's the sum of these and the sum of these. So all of them together, the sum of all the distances. So I'm going to add 51.9 to that, and I get 103.6. Now how do we use that to get our mean average distance? We take and we divide 103 by 18 because there are 18 numbers, and that tells us our mean absolute deviation. Divide by 18, 5.75. The lower this number, the closer everything is. I'm just going to say 5.76 rounded to the nearest hundredth. Okay, go ahead and round yours to the nearest hundredth. So that number tells me that the smaller this is, the closer my values are together. Okay,